Hi again. And so we continue to work with collisions, and last time we looked at perfectly inelastic collisions, and now this lesson we're going to look at inelastic collisions. Again, as always, momentum is conserved, but kinetic energy is not. Some of the kinetic energy is converted into other kinds of energy, such as heat, sound, deformation, just work being done on bending material. A common example is a car crash, where the vehicles may crumple, do work, and generate heat. Okay, so now we're not looking at cases where the objects are stuck together, but kind of move along after the collision as two separate objects, like most crashes are. So let's look at this car. A 2,000 kg car going at 30 meters per second collides head-on with a 5,000 kg truck going at the same speed. If it's a head-on collision, obviously it must be going in the opposite direction. What is the car's final velocity? We again start with our basic premise, which is that P initial equals P final. And so I'm going to call this vehicle 1 and this one 2. Again, it doesn't matter which one you choose as long as you remain consistent. So my initial momentum, m1 v1 initial plus m2 v2 initial, is going to equal to m1 v1 final plus m2 v2 final. Okay? And so we know that after the collision, the truck comes to a halt, which means its velocity would be 0. So starting with this is my M1, that's M2, that's V1 initial, and then V2 initial is the same as that, but in the opposite direction. So we have 2,000 times 30 plus 5,000 times negative 30, because if this guy is going at 30 meters per second this way, then he's returning back at 30 meters per second this way, and this would obviously be a negative velocity. So that gives me 60,000 plus negative 150,000 is equal to M1, which is 2,000 times V1F, which is what we're looking for, the final velocity of the car, car's number 1, plus 5,000 times 0, because the truck comes to a halt. Again, everything before the collision is here, everything after the collision is there. That gives me negative 90,000 is equal to 2,000 VF. That's a 2, doesn't look like it. No, I'm sorry. And so dividing both sides by 2,000, I get VF is equal to negative 90,000 over 2,000, which is negative 45 meters per second. So after the collision takes place, the truck comes to a halt and the car bounces back at that speed. Okay? So here's how we can predict what will happen post-collision if you know what happened to the final velocity of one of them. Next case, we have two objects here, and they are both going towards each other. They tell you the final velocity of the 4 kg box is negative 1 meters per second. That means he's going back, and we want to know what is the final velocity of the second object. Again, we start off with the initial momentum must equal to the final momentum. And so I have 4 times 4 plus 2 times negative 4 is equal to negative 1 times 4 plus 2 times VF. And again, I kind of skipped a step here. The P initial is M1 V1 initial plus M2 V2 initial, and that must equal to M1 V1 final plus M2 V2 final. And so that here is that guy there, that's him there, that's him there, and that's there. I kind of skipped a step, so I just want to go back and fill that in. So that gives me 16 minus 8 is equal to negative 4 plus 2 VF. That gives me 8 is equal to negative 4 plus 2 VF. I add 4 to both sides. Cancels, leaving me with 12 is equal to 2 VF, or VF is going to equal to 12 divided by 2, or 6 meters per second. So after these two collide, the 4 kg object goes backwards at 1 meters per second, and the 2 kg is going to go forward at 6 meters per second. Really important that we pay attention to the signs here, and if it's any velocity moving to the left or any speed towards the left, we would consider that with a negative sign, and to the right with a positive sign. Okay, let's look at one more example. 1200 kg dump truck traveling at 15 meters per second collides with a 600 kg VW bug, which is at rest. If the VW bug is knocked ahead 20 meters per second, what happens to the dump truck? Meaning, what's its final velocity going to be? So we again start off with the same thing. P initial must equal P final. This, of course, is for total. Total initial must equal total final. I'm going to call this guy 1 and that guy 2. And so I have M1 V1 initial plus M2 V2 initial must equal to M1 V1 final plus M2 V2 final. And so now I have 2000 times 15 plus 600 times 0 is equal to 2000 times V1F, which is what I'm looking for, the dump truck final velocity, plus the VW bug is 600 kg, and it moves forward at 20 meters per second. And so this gives me 30,000 plus 0 is equal to 2,000 V1 final plus 12,000. And so now I will subtract 12,000 from both sides, and that gives me 18,000 equals 2,000 V1F, and so this would become V1F is equal to 18,000 divided by 2,000, which is 9 meters per second. So this dump truck, which was originally traveling at 15, collides with this VW bug, which is at rest. It gives the momentum to him and loses that momentum himself, and now is moving at 9 meters per second. Real important thing to understand is there's only two things in our system. If our total momentum that we started off with was, in this case, 30,000 kgms, then the final momentum total is also 30,000 kgms. Anything he loses, this one must have gained. That's the only way it can work, because you could think about it as if you have, perhaps $1,000 between two people, and it's whatever happens, the total is always 1,000. You can only be giving one to the other, so they both may have 500. One might have 100. One might have 900. One could have -50, and one could have 1,050. But either case, the total must always be the same, because there's nowhere else to give it to. Any momentum he loses, he must have gained, or vice versa. Okay, real important basic concept to keep in mind when we're working with these questions. Next question, the blue car of mass 800 kg is moving with a velocity of 24 meters per second, collides with a red car of mass 1000 kg and a speed of 16 meters per second in the same direction. After the collision, the blue car continues in the same direction with a velocity of 14 meters per second. What is the speed of the red car? That should say red car. Okay, and so let's go ahead and work through this. Again, I start with the same thing. P initial equals P final. M1 V1 initial plus M2 V2 initial must equal to M1 V1 final plus M2 V2 final. I'm going to call this guy number 1, that guy number 2. And so, plugging in our values, we have 800 times 24 plus 1,000 times 16 has to equal to, the blue car continues to move in the same direction with 14 meters per second, so it's 800 times 14 plus M2, which is the one we're looking for, the red car, and that would have a mass of 1,000 kg times V2F. And so this again is the guy we're solving for. So let's go ahead and plug in our numbers. We have 800 times 24, that's 19,200, plus 16,000 is equal to 800 times 14, that's 11,200, plus 1,000 V2F. Combine these together, 19,200 plus 16,000 gives me 35,200 is equal to 11,200 plus 1,000 V2F. Subtracting 11,200 from both sides, I get 24,000 is equal to 1,000 V2F. So then finally, dividing both sides by 1,000, I get V2F equals 24 meters per second. So the final velocity of the second car, the red car, is now 24 meters per second. He was moving at 16 meters per second, and now after the collision he's sped up by 8 meters per second and is now moving at 24 meters per second, while the blue car which was moving at 24 meters per second, is now moving at 14 meters per second after the collision. So he lost some momentum and basically gave it to the other guy. And whatever he loses is exactly what the red car gains. And I have one real quick question after this. It's actually easier than all of these. And it's just asking the question in a little different way. Sometimes kids get confused, but really there's no reason to. I guess that question comes after this one. We have one more to go. These cars are going towards each other. They have a collision. The car A goes back at 4.7 meters per second. What happens to car B? Again, we start with our conservation of momentum. Initial must equal final. We'll call it A and B this time. That's what they are. Could use 1 and 2, but let's be a little different. MB/VB is equal to MA/VA, I'll call it prime, for final. We can just kind of be able to distinguish the two variables, plus MB/VB final. And so in this case we have 1000 times 5 plus 2000 times -2, and that's the key part to make sure we pay attention to that, is equal to MA, which is 1000, and he's coming backwards, so it's 4.7 negative, plus MB/VB prime. MB, of course, we know it to be 2000, so it's 2000 VB prime. I have an eraser. I could do better. Okay, so 2000 VB prime. And so this gives me 5000 minus 4000 is equal to negative 4700 plus 2000 VB prime. That gives me 1000 is equal to negative 4700. I think I put one too many zeros there. I have one too few. Okay. And so plus 2000 VB prime, adding 4700 to both sides. I get 5700 is equal to 2000 VB prime. So VB prime is going to be 5700 divided by 2000, giving me 2.85 meters per second. So we've determined that VB is going to be moving at 2.85 meters per second, and because this is positive, he's going to be moving to the right. Okay, so moving to the right, the final velocity would be 2.85 meters per second. Of course, that's positive, and so we know that this car is going to move to the right. Okay, now I have one last question, and that is the one which really is really simpler than all the others, but just something that kids sometimes look at and they go, I didn't see questions written like this. But so an object has a momentum of 80 kgms. It hits a stationary object, making the second one move. If the first object ends up with a momentum of 34 kgms, what is the momentum of the second object? Now, if you simply remember that whatever he loses must be gained by the second object. So if he had 80 kgms and he lost 34, or he's left with 34, so then if I subtract 80 minus 34, I get 46 kgms. So he must have given 46 kgms to the second object. that must be the momentum of the second object. This time we're not looking at mass and velocity, but total momentum altogether. So one object was going this way, this guy was at rest, he had 80, he had 0. Now moving on, this guy, he loses 46, so he's left with 34, and so he must have the other 46, so that they add up and give us the 80 back. So the initial momentum was 80, and the final momentum must also be 80. And when I say initial and final, I really mean for both objects together, the total. Okay, so that ends this little lesson on inelastic collisions. And next class we will explore impulse and momentum, and I'll do a separate video for elastic collisions for our on-ramps and AP students. All right, bye for now.
Thank you for watching. If you liked the video or found it helpful, please like us.